And with that, it is 7 o'clock. This talk is called Generic Data Types for People in a Hurry, and my name is Mathias, also known as IIS Reset Me. First of all, thanks to our sponsors. When we met in Vienna earlier this year, I very, very quickly went over the sponsors and thanked them, and a bunch of people found that very amusing. I just want to say this event could not be set up without the sponsors, so heartfelt thank you to them, actually. As I said before, my name is Mathias, better known as IIS Reset Me Online. Day-to-day, I work as a threat detection engineer at a travel tech company called Booking.com. If you want to know more about Booking.com, if you want to work in security engineering, anything like that, feel free to come find me on the floor after this talk. I do consider myself a bit of a PowerShell aficionado. I've been working with PowerShell for over a decade and have many opinions about the code that people write in this language or not. As of April this year, I'm also a community member of the PowerShell team engine working group, where we discuss sort of fundamental changes in the language engine. As I said before, I'm also known as IIS Reset Me, and you can find me on Twitter, GitHub, and the PowerShell Discord using this handle. If you have any questions or want to reach out to me or collaborate or just check out what I'm doing. So, the talk today, the agenda is going to be generic data types. What are they and why are they? We're probably not going to talk so much about why they are, but we are going to talk about what they are. We're going to talk about generic data types in the context of PowerShell. We're going to talk about some of the pitfalls that come with sort of the different runtime model that PowerShell has to some of the other .NET languages and sort of some of the caveats that come off that. And then for the remainder of the talk, we're basically sort of going to tour the generic data types that are already a part of .NET. And so here it says tour of generic BCL types. BCL stands for Base Class Library. That is the classes, the types, the code that comes with .NET Framework for free in PowerShell or any other .NET language, right? So as part of that, we're going to have a look at a few common interfaces. And so interfaces are these type contracts that sort of describe how a type, how a class is supposed to behave, which methods, which properties it should expose. And then we're going to have a look at some usual suspects. And by usual suspects, I mean very generic data types, things like lists, stacks, queues, and so on. These sort of abstract data types that can be used in any domain-specific context for solving specific problems related to the exchange of data, the exchange of information, right? And then finally, if we have time, we're going to have a look at some specialized collections. It might sound a little weird to talk about specialized generic collections, so I just want to point out here that the specialization and the genericism are really in reference to two different aspects of these collection types that we're going to have a look at. So again, generic types that have been specialized for a specific type of workload or a specific algorithm or a specific type of problem that you might be trying to solve in your exchange of data throughout your program, right, or your script. So what are generics? Did anyone in the room see my talk in Vienna called Developing Class Consciousness? Feel free to use the hands up sign by clicking the 6 button on your keyboards, the number 6. Okay, so a couple of people here in the front row, yeah, okay. So at least a handful of people saw that talk, and one of the points I made early on was that classes are object templates in the context of class-based object-oriented programming languages, right? Classes are object templates. So what is an object? An object is a thing, right? A thing that has data and code or behavior attached to it, right? And so data in this context is very broad. It's self-referential, right? An object can have members, fields, properties, and so on. And they themselves will also have a type, right? They are also objects, and they themselves can then in turn reference other objects, so on. Objects have types, right? They're constrained by types. This is what we have type systems for. It's part of the object's identity itself. And what I mean by identity is that we can distinguish between two different but similar objects, right? So I can create two instances or two copies of an object based on the same type. They can have the same values in their members, right? They can have the same or similar data attached. But because they reside in two different memory addresses, I can actually distinguish between A and B, right? These are two different objects, even though they might look the same when you sort of inspect them shallowly. Okay, so back to the question of what are generics. So classes are object templates in the context of .NET, right? Generics are the same. They're also templates, but they're parameterized. So this means that generics is a templating feature of .NET, right? Classes or structs are the templates for the objects that we want to create at runtime. Generics are templating for those templates. And what this means is that we can define a type or a class partially, and then it can be reused with different parameters, the same as when you write a PowerShell function, you parameterize it, and you can get different behaviors from running it with different parameters, right? So the idea of parameterization and templating and type templating should be sort of familiar to you, and the idea of sort of parameterizing a repeatable piece of code should be pretty comfortable to anyone who's written a function in PowerShell, right? But generics are a templating feature, and usually when we look at the names of a generic, the name of a generic type, right, like a class name, for example, it's very easily distinguishable from non-generic type definitions, because what you'll notice is that the identifier, in this case the class list, at the very far end, you'll see that it has some extra metadata attached, right? And so in CCS itself, you just need the count. You just need to know how many type parameters does this list have. And so sort of the native type system syntax for this is list backtick and then the number of type parameters. In C#, this is usually expressed by using a type placeholder. By convention, these type placeholders usually start with an uppercase T. If they're unambiguous, then usually just the uppercase letter T. And so this really means the C# syntax and the PowerShell syntax here. The C# syntax basically means I have lists and it has a generic placeholder, right? This is not a concrete type. This is a template for a type that you could create that will always behave the same. In PowerShell, the equivalent syntax would be list, and then we use square brackets instead of the angle brackets for the type parameters. If you type this into PowerShell, it's not going to work because PowerShell will attempt to resolve T, right? So the T in a list of T or a list T has no meaning to PowerShell, right? PowerShell says like, what is this? I don't know what you're talking about. So when we describe the generic type definitions themselves, so these unclosed types, these types where we're sort of leaving it open what they are to be used for, we use the CTS syntax in PowerShell, and we're going to have a look at that once we get into the demo. But so the CTS syntax is for describing a generic class or a generic type without specifying what the actual parameters are, right? So it's not really usable. You can create a copy of it. You can create an instance of it. It's just a description. It's a template for the classes that we might want to instantiate later. Finally, here I want to shout out to the original generic type, right? Generics were introduced in not up front, but in a later version of .NET. And up until generics were introduced into .NET and subsequently into VB.NET and C#, the only kind of typed collection that you could instantiate was the array, right? You can create an array of objects, you can create an array of strings, you can create an array of integers, you can create an array of whatever data type is available out there. And the array will behave the same, right? If you try to use the index of function, you're still going to get the index of whatever value you pass as a parameter argument, regardless of the fact that the type of sort of the contained item that, like, regardless of what is contained in the array itself, the behavior will always be the same. So we can sort of reuse it, but still get type safety, right? Like an array of strings is not going to contain a bunch of integers. We can say up front that it contains strings and it's only going to contain strings, right? So then the second question is, why are generics, right? And so this is a super oversimplified, non-comprehensive explanation of why generics is. But basically the support for generics, so the support for type parameterization and class definitions or type definitions in .NET was introduced in .NET 2.0. It became the basis for a bunch of massive changes in both C#, .NET, and VB, and Visual Basic .NET in version 3.5, and this particular release included something called LINQ, L-I-N-Q, language integrated queries. And so the idea here was that, as you can see on sort of the far right of the slide deck here, is that you can write inline in your C# source code something that looks a little more like a structured query language, right? It looks a bit more like SQL. Many of you, even if you're not database administrators, right, you're probably familiar with these family of structured query languages from things like WMI, right? WMI has its own query language dialect called WQL, WMI query language, that again sort of allows you to write sort of SQL-like queries to interrogate the instances in the classes in the WMI repository in your machine, right? And so this was introduced in C#3 with the release of .NET 3.5. And one of the problems here is that when you write a query like this from name in names where the first name starts with an M, select name, blah, 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 in order for the query analyzer to be able to say whether this is a safe and valid query, it needs to be able to infer what it's selecting from, right? So it needs to be able to figure out what is the type of names. And so names in this case, if you look at the very top of the code example, it very clearly says list string, so a list of strings, right? And so from here on, now that we have this generic type parameter string as part of the type of names, LINQ and the LINQ query analyzer can now infer that what's coming out of that query is going to be a string, because name was selected from this collection called names, and names consists of strings, right? And so the introduction of generics solves a bunch of problems with compile time type safety in C#, which is also the answer to the question, why have I never heard about this before? Because I suspect that some of you are sitting out there right now going, I've been using PowerShell for a number of years. I've never had to learn anything about generic types in .NET. I've never had to instantiate a generic list of any kind. Everything works just fine. I'm just using arrays and hash tables and ordered dictionaries, and I've never had to care about this. What is this about, right? And so in order to understand why this is super important, actually to PowerShell as well, and in C# specifically, but why it isn't important in PowerShell at all, I want to introduce you to my favorite snowverism. So a snowverism is something that Jeffrey Snover said at some point, right? And my favorite snowverism is PowerShell is like programming with hand grenades. Now, this might not make sense. It sounds kind of funny, right? Like PowerShell is like programming with hand grenades. Who wouldn't want to program with hand grenades? That sounds pretty fun, right? But sort of the full extent of the quote is, if C# is a rifle, then PowerShell is like programming with hand grenades, right? And so the idea here is that in C# you get a lot of accuracy, but you need to work for it, right? You need to train with your rifle. You need to train your aim. You need to make sure that everything is sort of really nice, and there'll be a lot of ceremony that comes with that, right? You'll have to write a lot more code than maybe you think is reasonable. And so at this point, Jeffrey Snover says, maybe we can take some of these things that are annoying people in C# 2.0, right? The first two versions of C#, and then maybe we can make like a nicer runtime environment that takes care of some of these things, right? So the real answer to the question, why have you not had to care about generics using PowerShell for the last 15 years when this has been a feature in .NET for the last 15 years? The answer is very simple, right? PowerShell and generics and LINQ for that matter were developed in parallel, right? .NET came out in 2000, 2001, and for the first 6-7 years, this idea of generic type parameters in class definitions simply did not exist, right? So in the middle example here, so classic .NET pre 2.0, pre 3, if you do a for each loop over an enumerator, we'll talk about what that is later, but if you do a for each over an enumerator, then the only output type from the enumerator is necessarily object, because you don't know right? We don't have a generic type parameter to tell us whether the enumerator is going to return a string or an integer or something like that. And so you need to write really ugly code like this for each object in enumerator. And then once you get into the loop, you need to cast it, or you need to type check, or you need to do sort of a bunch of things, write a bunch of codes to do things that you as a developer are looking at your code going like, why do I need to guard against this? This could never happen in the first place. But the compiler does not have enough data. It does not have enough metadata to be able to say, actually, you don't need to take all of these precautions. Just go ahead and write the code you want to write, right? And so PowerShell found an alternative solution to this problem while the C# language development team was looking at how they could solve this with generics, right? So Jeffrey had the wonderful idea of saying, what if we just take the lifecycle model of the code and we all just squash it together, right? So from source code to code actually executing on your machine, that's like a single atomic operation, right? We pass the code, we compile the code, we check the code, and then we execute it instantly, right? And so in this sort of just-in-time compilation model, a bunch of things can be deferred to runtime, right? A bunch of things that would have failed in a C# compiler, we can just say, we're just going to wait for it to fail at runtime, because runtime is 10 milliseconds from now anyways, right? And so PowerShell basically solved this problem by saying, oh, we're just going to defer all type checks until runtime, and if it matches, we're all good. Otherwise, we're going to fail at runtime, and then that's just the way it is, right? And so PowerShell has a bunch of nice error handling around to sort of make it easy to use when you're programming with your hand grenades, right? And this is sort of how PowerShell came about, right? So generics, again, is a solution to a problem that PowerShell doesn't have, which is exactly why you might have gone for the last 15 years, or at least the last 5 or 10 years, using PowerShell without ever having encountered a situation where you had to know about generics internet. As I said, we're going to talk a little bit more about generic types, specifically in the context of PowerShell, right? And some of the caveats that maybe make generic data types a little bit of a headache to work with if you sort of dived straightforward into this topic out of curiosity or whatever. You might sort of have hit a wall at some point, right? And so just to mention a couple of things, conversion semantics sometimes conflict, right? Again, generics and PowerShell are trying to solve a similar or sort of adjacent problems into wildly different ways. And so that means that the conversion semantics that the .NET type system expect the compiler to enforce are not necessarily the same as what the PowerShell language engine are going to enforce, right? So conversion semantics might version 4 extension methods for generic collections. That's not entirely true. If you do where or for each on a list, for example, it'll work, but the where and for each extension methods do not work consistently on generic collection types. So that's just something to keep in mind. Maybe you don't use the where and for each extension methods that were introduced in 4.0, then you don't have to care about that. Type discovery via reflection is a little bit complicated. Again, we need to sort of include all the information about which parameters go with which type and so on. And so again, type discovery via reflection might be a little bit complicated. There's another complication, again, owing to how PowerShell was designed to solve the problem differently, is that PowerShell loves unraveling enumerables. What is an enumerable? Again, we'll talk about that in a second, but many generic collections implement an interface called IEnumerable over T. So a countable collection or an enumerable collection of T, right? And so whenever PowerShell sees anything that implements IEnumerable, it loves unrolling it. And since the default array type for PowerShell pipelines is just object array, you might end up in situations where you store a generic collection in a variable, then you do something on the pipeline, and then all of a sudden you find out that your variable no longer contains a generic collection type. It just contains an array because that's what the pipeline outputs. So keep that in mind when you're using the pipeline directly with some of these collection types. PowerShell will, intercede and try to rip it all apart for you. That's part of PowerShell's behavior. It's part of why we love PowerShell, right? But keep it in mind if you're working with the generic collection types. This also goes for non-generic collection types, right? So again, regular arrays get unrolled. If you have a strongly typed array, and you use it with pipeline, again, you end up with a not so strongly typed array, right? And then finally, there's also a slight cognitive strain from the extra templating layer, right? Rather than just thinking about, oh, I have this thing over here, you need to think about some extra parameters for it as well and what the implications of that are, right? So you might also have dived straight headfirst into this topic and gone like, this is giving me a headache, right? As I said, we're going to talk a little bit about sort of common interfaces used by generic types that come with the base class library and sort of what they're for. I already mentioned IEnumerable over T and its companion piece IEnumerator over T. And enumerable in English means countable, roughly, right? So an enumerable is a collection that you can take one by one and start doing something with it, right? Like counting it or throw it through a for each loop, right? In a language like Python, we might call these generators. In a language like Java, we would call them iterables or iterators. It doesn't really matter what we count them. This is the base functionality for taking a collection and then unraveling it one by one, right? Give me the next, then the next, then the next. This is sort of the basis for the for each loop in PowerShell, for example. Anything that implements IEnumerable, with a few exceptions, you can feed them to your for each loop, right? Or to the pipeline operator. The next common interface I want to talk about is the iCollection over T or over T value. Doesn't matter, these are placeholders. These are for collections, very broadly speaking, right? So things that allow you to maybe add something, maybe remove something, and it'll give you a flattened count, right? So it's going to allow you to keep track of like how many items are actually in the collection without enumerating the entire collection. Then we have iList over T or over T value. Again, this is for types that implement lists or list-like behavior. And so again, it takes the iCollection interface and then extends it further by adding indexing. So again, we can sort of take our square brackets, right? We can go array, square brackets, give it an index, the number 0, for example, for the first item in an array or a list. And so we can do this with anything that implements the iList interface. This sort of extends the classical idea of lists, you know, like linked lists, for example. It sort of merges it with the concept of a dynamic array, right? So we end up with a data type that is dynamic, right? We can resize it, we can add to it, we can remove from it without worrying about whether we're filling it up, right? Like we're going to write out of bounds, but we still get the array random access behavior that we're used to from a normal array, right? We can index into it. Finally, there's a couple of other common interfaces, but these are sort of like, these are the most common. I should note that this is a hierarchy, right? Anything that implements iList necessarily implements iCollection. Anything that implements iCollection necessarily implements IEnumerable and will return an IEnumerator. Finally, the last interface I want to talk about is iDictionary. Two things of note here. First of all, it's the first type we've looked at that has multiple type parameters. So this is pretty interesting, right? Because a dictionary or a map, as we might conceptually call the abstract data type that it's sort of trying to implement, has two things, right? It has a bunch of keys, and then the keys are mapped to a bunch of values. The keys can have a type, and the values that are stored can have a type. So here we have two type parameters, one for the key and one for the value. In addition to all the existing functionality of lists, collections, and enumerables, it adds keyed lookup. And so what's keyed lookup? Well, keyed lookup is the idea that you can give it the key, and the dictionary or the map will tell you, yeah, I do have a value associated with said key. So again, very useful for keeping track of a bunch of data by unique identifiers, right? One thing I want to mention here, as I just said before, PowerShell loves unraveling things, right? It loves sort of enumerating enumerables. But there is a stopgap in place in the PowerShell language engine. And so basically anything that implements any of the first three interfaces, IEnumerable, iCollection, iList, we could also just say anything that implements IEnumerable, will be unraveled by the pipeline and will be accepted by the for each loop language construct. There is a couple of exceptions to this. One is the iDictionary interface. Any type that implements the iDictionary interface sort of silently has its enumeration or its implicit enumeration neutered by PowerShell. PowerShell says, oh, this is an IEnumerable, but it is also a dictionary, and I'm not going to enumerate it because that's probably not what people want, right? Usually you don't consume a dictionary as a list, right? The same goes for strings, and there's a couple of other types that, again, implement IEnumerable over some types. String is an enumerable of chars, right, or of characters. And so anything that implements IEnumerable and is not either a string or an iDictionary, or I can't remember the whole list, is going to be unraveled by PowerShell. But this is basically why you can't do for each, var key value item in dictionary or in hash table. It's not going to work. The hash table is going to be treated like a scalar, even though it does actually implement the requisite IEnumerable interface. So, okay, so this all sounds very complicated. I've talked a lot about like what limitation it imposes and why it isn't really necessary for PowerShell in the first place. So why would you even listen to me, right? Like, first of all, curiosity, right? This is sort of interesting if you want to learn about C#, if you want to learn about .NET. So if you're curious about it, please go ahead. The other thing is that there are actually a couple of sort of tangible upsides to it. If we use generic collections, that is collections with these generic type parameters, then we get the performance of whatever the collection type is optimized for, right? But we don't sacrifice type inference. And what does that mean? Well, that means that when you're doing things on the command line or in your editor, the autocompleter actually has a living chance of trying to predict what's going to come out of, let's say, an enumerator of a collection over a specific type, right? So again, we get some added author-developer functionality without sacrificing performance for whatever abstract data type we're trying to leverage, right? Generics is also pervasive in modern.NET, right? Like if you started learning C# today, you definitely have to contend with this issue. And it also enables a bunch of use cases sort of outside PowerShell, right? So the first example that comes to mind is over the last couple of years, I've had to write a bunch of client code for MongoDB, the popular document database, right? And MongoDB's .NET client SDK is entirely tuned around Mongo-specific collection types over domain-specific type parameters, right? So if you want to work with the MongoDB SDK in PowerShell, for example, you need at least sort of a rudimentary understanding of how to construct these types and how to use them and so on and so on. So again, this will be a very small subset of users, but some users will run into situations where learning about .NET is a must simply because they need to interface with SDKs or libraries that are tuned around generics. Finally, .NET is also filled with hooks for generic interfaces, and even PowerShell is, right? If you want to do advanced hosting scenarios where, let's say, you spin up a couple of background run spaces or a run space pool and attach separate PowerShell instances to those, if you want synchronous input and output, so like the ability to feed the PowerShell process input and take output from it while it's still running, you might have to contend with something like PS data collection over type T, which is a generic collection that PowerShell uses for input and output moduling. So again, it might very well be that you've never had to use this, you've never heard about it. What I'm about to show you is going to be really weird and strange and alien, but it's also entirely possible that you come into a situation where you just can't get around the fact that you need to sort of develop a bit of an understanding about what's going on here. All right. Finally, the title says in a hurry, right? And so what I want to do for the, I have more than 15 minutes for demos, excellent. What I want to do for the remaining 15-20 minutes is I want to look at a couple of generic collection types in .NET. I want to look at how we can discover them. And then as sort of the an extra, we're going to have a look at some of the performance characteristics of some of the different abstract data types that are already available in PCL. And so the tool I'll be using for this today is primarily measure command, right? Measure command built into the utility module. It executes your code with a stopwatch, and then it just tells you how long it took to execute, right? Simplest tool in the world. We might get into a situation where we want to inspect sort of a little deeper what's going on, or inspect line by line what's going on in the execution engine. For this, I would use measure script from my own module, PowerShell Profiler or PS Profiler. Finally, if you have more complex code bases, right, you're doing performance investigations or profiling for optimizations, go out, find Jakob's profiler module on the PowerShell gallery and use his trace script commandlet, which will give you sort of way deeper insights into the performance characteristics of the code you just ran. And then finally, I feel like I haven't done a good enough job of this in the past, but please remember, when you're writing code, right, you're writing a PowerShell function, you're writing a module, you're writing a specialized data type for something you need somewhere, optimize for correctness first, performance last, right? Obviously don't make choices that would expose you to performance penalties if you know how not to, but it should not be the first thing on your mind, right? Optimize for correctness first. Once you have code that works and works well, you can start going back and then sort of inspecting where some of the sinks where we lose performance or we lose execution time, right? With that being said, I think it's time to just jump into demos for the next 15-20 minutes. So what I have here is the latest version of Visual Studio Code with the PowerShell extension. I think we are on version 7.25. We are on 7.2.6, right? Okay, so we're on the latest stable release of PowerShell 7. And so what I'm going to be doing here in the first demo is, before we jump into and actually start creating and playing with some of these types, is I just want to give sort of a shout out to how you can discover what might be available. One way to discover the kinds of types that are available is to review the documentation, right? You could go to docs.microsoft.com, navigate to the .NET API Explorer, find the systems.collection.generic namespace or wherever some of these types are, and then start reading the documentation and have a go at it, right? That's one option for discovering these things. But these types are not always in the same place, right? They might be defined with different namespacing in .NET. And so a better way, I found at least, if I want to get an idea of what's sort of available to me out of the box, is I just open PowerShell without a profile. It's like, don't load any dependencies, just PowerShell, its core modules, and then the base class library from .NET. And then what you can do is this very simple 4-step process for discovering types that are generic type definitions. If you have a module like Patrick Meinecke's PS Class Explorer, you could also use that to discover this. This would probably be easier, but I'm going to assume that you just sort of have a vanilla PowerShell setup and you want to know what's available out of the box, right? So what I'm going to do here is basically the steps, I sort of wrote them up here, is we need to get a reference to the current app domain. The app domain is sort of the logical runtime container inside the process that hosts the .NET runtime we're sitting in. And so attached to that will be all the assemblies that have been loaded from disks, right? All the DLLs that have been imported, any dependencies that PowerShell has imported, so on and so on. Okay, so if I just have a look at this property here, right? Okay, so it's going to give me the application domain that's currently active, right? So what I can do here is I can call get assemblies. Just have a look at the type, the signature of that. Right, so get assemblies is going to return to me an array of assemblies. Okay, assembly objects have a method called getTypes, which is going to just return all the types that are defined in that assembly, regardless of whether they're public, private, whatever it is. Any type definition in the assembly itself is going to get exposed via this, right? And so I'm going to get all the types. I'm just going to execute this, and it took like a second. And so now we've discovered that our current application domain, right? Okay, so this is the PowerShell host inside VS Code. There are 27,000 types available. Obviously, not all of these are relevant to what we're doing here. So if we start by filtering for non-public types, okay, we're down to like 7,000 types that we could use for various things. Okay, what we're really interested in today is a public class or a public type definition that has a specific property called is generic type definition. If this flag on a type literal is true, then it means that it's one of these unclosed generic type definitions, right? A type definition that cannot be instantiated, but if we supply some type parameters to it, we can get a specific variant or a specific version of it. And so if we do this, the count is down to like 553. See, so there's a bunch of stuff here, and so there's a bunch of I'm just gonna make this a little bigger. So you can see there's a bunch of stuff here living in different namespaces. Let's try and group them by the namespace that they're part of. So I'm going to use the group object commandlet here, and I'm just going to group them based on namespace. And so we can see here a bunch of these type definitions. Actually, I'm just going to sort by group count here. So what we can see here, it's sort of cut off here a little bit. What we can see here is that the second biggest namespace container of generic type definitions is system.collections.generic. Okay, very well. So if we have a look at that namespace, system.collections.generic. And then we're just going to use like the autocompleter here to see. Okay, so we have a dictionary type that probably implements the iDictionary interface. And so in the name, it has something called a hash set. It has some stuff for doing async enumeration. It has the iCollection interface that we talked about before. Actually, all of these interfaces that we were talking about before, they're all defined in here, right? And so, so we can do something like, we go up again and say types, where it's public, is generic type definition, and then we want anything that ends with word list. We need to include the type parameter. No. All right, so here we can see a bunch of interfaces for different types of lists. We have sort of the generic list type down here. There's also a sorted version. Okay, this looks pretty interesting. And then we have sort of the classic linked list that also comes with .NET. As you can see, again, from the -1 here, they all have exactly one parameter, right? With the exception of sorted list, which sort of makes sense, right? Any kind of list you could think of contains a single thing, right? You wouldn't have a list that contains something and then some other thing. Okay. So now that we sort of have an idea for how to, I'm just going to paste it up here. Now that we sort of have a reference for how we can discover some of these types, let's jump in and have a look at what we can use them for. And so some of you might have seen something like this before, right? So system.collections.arraylist. This is another collection type.NET. Unlike the generic collections that we're looking at today, this has been around since .NET 1.1, I think, or at least 2.0. So if you look at code written for PowerShell 2.0, for example, that can't guarantee running on .NET 3.5, you've probably seen a lot of code that does this, right? You cast an empty array to an array list that gives you an array list instance, and then you can start adding things to this, right? Without getting the performance penalty that you would get from doing PowerShell sort of natively resizable arrays. Like if I remove this, then I would still be able to add to the array with the addition operator, but I'm going to take a huge performance hit, right? So one way of getting around this is to use an array list instead. But array lists have an extremely annoying behavioral side effect. So what I'm going to do now is I'm going to generate 1,000 random numbers, and if they're over some threshold, in this case 1 billion, I'm going to add them to my list here, right? And so I'm going to execute this, and let's see what happens. Run selection. Here we go. So you see, it starts outputting a bunch of numbers here. And so if you've contended with this problem before, you probably know what's going on already. That is, there's an extremely annoying side effect of the add method defined on the array lists, which makes it output the index at which it inserted a new item, right? And so in C# this is not a problem because values output from a function that aren't assigned to anything are just discarded, right? Like the C# compiler doesn't doesn't care about it, right? Like forget about that immediately. But PowerShell is a little bit different, right? Anything you output inside a function is going to be sent as output regardless of whether it matches the output type of the function itself, right? And so PowerShell is just going to push everything out the output pipeline. And so that this means that if you write a function or a commandlet where you use the arraylist function, right, and you call add, then all of a sudden the output from your function has been polluted by all of these numbers at indexes at which you inserted stuff into the list, right? And so this is extremely annoying. And so the simplest solution to that in the entire world is to take the code you already have and then just change the part where you create an array list. And then what we're going to create instead is a list. Let's see if we can get this to... Okay, so since we're creating an instance of this list, we need a concrete type, right? And a concrete type is one that we can create, right? It's not just abstract, it's something we can create. And so for that, we need to fill in the placeholders, right? Remember before in C# we might call it a list T, or the generic variant we might call it list backtick 1, right? But here, when we actually want to create one of those, now it's the time to tell it what the type parameter actually is, right? And so in this case, where getRandom is going to output a bunch of integers, the item type here is going to be int. So I'm going to just put it in here, and we're going to run this code. And what you'll notice is there's no annoying output from calling list.add, right? The definition for ilist.add is void. It doesn't output anything. So now you get the exact same performance characteristics that you obtained in the first place from switching from an array to an array list, but you don't get this sort of annoying behavior with the add method, right? In order to sort of prove that I haven't made this worse, we're just going to do like two simple measurements here. We're just going to execute both of these again. We have both of these pieces of code, one operating on the array list, one operating on the generic list that's been typed to an integer. We don't need to worry about the output right now because measure command is going to swallow it all. But for, again, correctness, the thing we optimize for first, you would have to either void cast or pipe it to out null or redirect it to the null variable or something like that, right? So let's just do this again. And so if we run both of these and try to measure what's going on, we see that they have pretty similar performance characteristics. And I can see that Evgeny is saying in the chat there is no guarantee you'd be adding the same amount of items because the values I'm evaluating are random. That is absolutely correct. So in order to prove that that's not actually what's going on here, I am going to generate a sample set of values up front instead. And so we're just going to call getRandom 1,000 times and output it to this variable sample set. And then it's going to be the source input data. Okay. Instead of generating it on the spot, I'm going to take our pre-selected sample set here. So that's Evgeny, does that solve your? Does that address your concern? I'm going to assume it does. Yeah, excellent. Okay, so if we run this again. What's going on here? What is it complaining about now? The index operation. Oh yeah, of course. We need $_ because we're using for each object. Okay, so run this again. And you still see they have pretty similar performance characteristics, right? Unlike an array, we're not seeing like 100 millisecond overhead from having to resize all the time. A couple of milliseconds for 1,000 items. Yeah, that sounds about right. All right. So that's the list, right? One thing I mentioned before is that the conversion semantics in Ling are a little bit weird, right? And so you might run into situations where it says, oh, I can't take this list type and convert it to this list interface or whatever it is. one of the safest options for when you don't know how to type the collection in the first place is to just use psObject. psObject implements something called iComparable that it proxies back to the object that the psObject wrapper is wrapping. And that means that even if you use list psObject, things like sorting lists will still work with integers and strings and other things that are comparable. So again, if you don't know how strictly to type type parameter for a collection you're using in PowerShell, type a psObject and you're going to get a lot of behaviors for free, and probably what you're trying to do is going to work. All right. Obviously, we measured sort of the performance characteristic of inserting a bunch of stuff into these lists, right? And so if we do a comparison, I'm not going to do that right now because I have more stuff I want to go through. But if we compare this to doing the same thing with an array and the plus equals operator, right, adding to a dynamically resizable array, if we did that, then we're going to see that the list and the array list are going to be way faster than the array. And so you might go away from this demo thinking to yourself, excellent, lists are super fast, arrays are not, I'll just use lists all the time, right? The problem here is that the specific problem we're trying to solve is that we're collecting a sequence of data, right? And we're just sort of adding on to the end of it. If we had different requirements, let's say that we needed to maintain a list that was insertable from the start, from the top, right? So we sort of want to maintain a reverse order. If we start doing that, we might see some wildly different performance characteristics, right? So I'm going to do the exact same thing that I did with the generic list here to reproduce the non-generic example. Again, we're just going to create an empty list. And so what I'm going to do here is I'm going to use list insert, because insert allows us to specify the index in which we insert it, right? Add just adds it after the last current index of the list. So what I'm going to do here is I'm going to use list insert, and I'm going to insert at index 0, right? So at the front of the list. So this way I'm sort of maintaining the order of the list backwards relative to the input insertion order. And so if I execute both of these, so we're just going to add like a dummy item here. I'm just going to add the why is that not working? The index goes first, right? So insert into index 0, some value. This is what I said before. If you're in doubt with any of these things, just read the documentation. It usually helps. And so we're just going to remove them. And so here we see that, okay, we run it on a sample set from before, and it appears that adding it to the end of the list is at least twice as fast as inserting them at the front of the list. So, okay, what if we up the sample size, the input size? Because this is really what we're trying to get to here. We're trying to get to the limiting behavior of inserting into this list. So I'm going to regenerate the sample set with 10,000 items instead of 1,000, and then we're also going to again. And so again, you can see sort of like the adding on to the end of the list sort of consistently wins out against trying to insert anything up front at the start of the list. And so what we can learn from this is that lists have wildly different performance characteristics based on where or how you insert into them, right? And so if you're in a situation where, again, you want to maintain a collection of items, but you want to sort of reverse the order, right? You might want to pick a different generic data type. And so the next example we're going to look at is the stack. So I have an example here of a non-generic stack. I should note here that we're already over time. I'm going to keep talking for the next 10, 15 minutes until we've gone through some of these examples. If you want to stay for it, please be my guest. If you have something else to do, the talk is over. But otherwise, I'll also be around all night answering questions out on the floor if anything needs anything. But I just wanted to make you aware that the session is technically over, but I'm just going to continue until Gail kicks me off the stage. Okay, so what is a stack? A stack is a data type that supports what we were just discussing, sort of inputting at one end. The problem with stacks is that you can also only read from one end, and this is sort of where it gets its name from. It's a bit like a stack of plates that you might have seen like in the canteen at your workplace, right? You stack you put a plate on top and it sort of bounces down, and then you put a plate on top, and you always have access to sort of the top level plate that you put on top of the stack, whereas you can't reach the bottom, right? Okay, so Bartek just mentioned that the code example I have here in the here on screen looks very much like a solution to last year's Advent of Code, and that is absolutely true. I did indeed use this to solve one of the Advent of Code problems last year. Nicely spotted, but this is actually not that. It's maybe not an it's maybe not a very common use case, but it's kind of an interesting use case. So basically what I want to do here today is I want to write a function that can test whether a string containing a bunch of parentheses are balanced, right? And so by balanced, I mean that every time we open one, we also close it again, right? And we can't close a parenthesis that we haven't opened, right? So this string is not balanced, right? It ends with a closing parenthesis, even though there are no preceding opening parentheses, right? Whereas this is perfectly balanced. We sort of open one parenthesis and close it again. So I've written this function. I thought if someone saw this and they had never worked with a stack before, it would sound really weird. So this is sort of the simplest example I could come up with. So the idea here is that we take the input string, and then we just walk through it one by one. And every time we see an opening parenthesis, we push its counterpart onto the stack because we're expecting to see its counterpart at some point in the future. We continue doing this. Every time we see an opening parenthesis, we push its counterpart onto the stack as the last parenthesis that needs to be closed. But then as soon as we encounter a closing parenthesis, we just pop from the stack because the last thing we put on the stack, that is the last opening parentheses, and that should be the next thing we're met, right? The last parenthesis we open should be the next thing we're closing, right? And so if we continue doing this and we encounter a situation where there's a closing parentheses without a matching opening parentheses on the stack, then we return false, right? And similarly, if we get to the end of the, let's say input the string, right, we get to the end of the loop and we have a bunch of open unmatched parentheses, then obviously the result that we output is based on whether they exist or not, right? So if we remove those again, the stack count should be 0 by the end of the function. And so we can test this, run this, and yeah, sure enough, test parens balance, this statement is balanced, right? And so again, I can add something to make it unbalanced, and test parens balance is going to make it false. Again, just like, well, not quite like the array list, but as you can see here, I have a non-generic stack. It's a stack that contains objects, right? Again, there's no indication here that what I'm actually pushing into it are like one-length strings, right? Like nothing tells you, oh, I want to hold strings for you, right? So it's just a stack of things, a stack of objects, whatever type they are. And so in order to turn this into using the generic version of stack is super easy because the generic version of the stack lives in this namespace that we were looking at before. And just like lists, it only has a single type parameter, the type of item that we can push on top of the stack or pop off it. And so again, in this case where the thing I'm pushing is a string, I'm just going to use string. Again, this example would have worked as well with PSObject because a PSObject can meaningfully wrap a string. So PowerShell would sort of automatically just pass the PSObject wrapper rather than the string value itself. And that's basically it. The queue, the stack, and the dictionary types are designed so that you can basically use them as a drop-in replacement for the non-generic or the non-typed collection types that existed prior to .NET 3.5. So again, if you have a piece of code that uses a collection type like stack or the non-generic queue or anything like that, the only thing you need to do in order to get the generic version of it is target the requisite namespace and then provide an appropriate type parameter. Again, if you're unsure what an appropriate type parameter looks like, or if you're just exploring, right, PSObject, it'll accept anything in PowerShell. All right. I skipped queues because that's basically the same example, right? Like rewriting a piece of code that uses a queue to one that uses a generic queue is, again, just changing the namespace to the generic type and then add the type parameter for the items that you want to contain in the collection. Okay, let's look at something else instead. The only example I had on the list of common interfaces that you should learn about that has more than one type parameter is the dictionary, because it needs a type parameter for both the key and the value. And so, again, if you've been a PowerShell user for a long time, you might sit here going, why would I ever use this, right? Like, I have my hash table. I even have like the ordered dictionary that preserves insertion order from PowerShell 3.0. What could I possibly have to win by adopting some of these generic versions of things I already have? And so that's an excellent question. I'm not here to argue that you should stop using your non-generic types. If you have code that's correct and you don't have any performance issues with it and it otherwise works just fine and is maintainable, I'm not here to tell you should change anything. But with dictionaries specifically, there is actually a little bit of value add, right? There is a little bit of sort of extra things that we get for free. And so what we can do here is, so this is like a very simple contrived example of how to use a dictionary, right? So we use the hash table literal syntax, right? @ sign, open curly braces. Then we have a list, either new line or terminates, statement terminator separated list of keys and values, right? So this is the key. PowerShell's literal syntax allows us to just sort of plop the key bare word in here. Like we don't need to add any quotation marks or anything. But there is a problem with hash table, right? With the hash table is that since the keys are untyped, that is, they can be of any kind, right? Like you could take an object, right? You could do, I could create an empty object, no members, it's completely useless, right? Like this is just a memory address somewhere in my runtime. I'm not going to use this for anything, but this is a value dictionary key, right? I could create a hash table. I'm not sure it's going to work with the literal syntax actually, but I could create a hash table, right? And I could use that empty object as a key because it has an identity, which is all the hash table needs. So I could put object here, right? And I could say that the value is 1, 2, 3. And then the only way to get to that value, again, is to supply the object that has the same memory address, right? So again, I can get it here, but if I create another identical object, not going to work because they don't have the same memory address, which is what the hash table uses to figure out whether it's the same key or not. And so this problem that PowerShell needs to take into account that the hash table key can be anything. PowerShell will do absolutely nothing with the key values you provide, and that means that you can sometimes get into situations where you store something in a dictionary with a numerical value, right? Say that you, by the way, never do this, but it is perfectly valid. You do something like this, and then at a later point in time, these two zeros are not the same anymore. And so hash table key will no longer give me the value, right? And so there's a solution to this problem, and that is strongly typing the keys of your dictionary. How can we do that? We can do that by using the generic dictionary key. So what I can do instead is, again, let's say what we need to remember here again is that we need to provide two type parameters, right? So one for the key, and so in a case where you wanted to use numbers, maybe you should use an array, but maybe your data is non-contiguous, right? There might be good reason to use integers or numerical types as dictionary keys. And so I say something like this. Yeah, let's create a new one of this. Now, if you do dictionary, now since PowerShell can see that the indexer for this type of dictionary accepts an integer key, it's going to automatically convert this long to a normal int, and your lookup will then work again, right? So again, the dictionary type is actually one of the few where if you want to make PowerShell sort of less annoying in the way it maybe interferes with your dictionary key lookups, there might actually be some value to be gotten from strongly typing the keys of your dictionary. Be aware that this also means that there are some things you can't do, right? So nothing is stopping you because hash tables values. It also means that I can do these sort of weird nested data structures, right? So I can say Q1, the value is just another hash table, which again has another hash table and so on. And so like I can sort of devolve into this sort of hierarchical data structure using hash tables. And I can do that because hash tables are not typed, right? The hash table does not care that the value is another hash table versus a string or some other type of object, right? And so this you won't be able to do anything anymore, right? Because as soon as you try to assign a hash table to one of the entries in this dictionary up here, PowerShell is going to say, well, I can only pass string values to whatever method is going to add to the dictionary. So PowerShell is either going to convert it to a string or give you an error that it cannot be converted, right? And so again, there are some. It sort of imposes some limitations, the kinds of choices you make when designing sort of the parameterization of your generic data types. Finally, sort of the last sort of usual suspect in the system.collections.generic namespace that I want to talk about is the hash set. Some of you might have come across this before. Some of you might not have heard about it before. A set is a mathematical concept, right? It's a collection of unique items or distinct values. And so the idea is that we can take a bunch of data and we can throw it into a set, and then we can sort of look at what sticks in the set, and then we have all the distinct values in the original collection, right? So as an example here, right? Actually, let's just do this contrived example first. So I have a collection of 1 million numbers, a little more than 1 million numbers here. I'm just going to generate this. Okay, so I have an array of more than 1 million numbers. I'm going to seed an array with 10,000 of these numbers, and then I'm going to take another 1,000 numbers out of that same pool as a test sample. And then what I want to do is I basically want to test the overlap between these two collections, right? I want to see how many of the sample values I gathered for my test sample are actually contained in the original array that I created from the same set of data. And so obviously you can do this with something like the in operator, or we can also, to make this a little more PowerShell 2.0 compliant, if that makes anyone more comfortable, also turn around and say array contains, right? But basically we're using array containment operator to test whether the array contains either one of the values of test sample that we're iterating over, and then since we're nesting it where object, we're going to get the resulting overlap, the values that are both in test sample and array, right? And so if I run this, I'm not going to run that first one. I'll run for a bit, still going to run. So this is pretty slow, right? And the reason this is slow is that at every time we do this contains operator for a value that is not contained in the array, where object or the contains operator needs to iterate over the array one value at a time and test every single one of them, right? And so that means that for every single input value that does not exist in the array, it's going to take the maximum amount of time searching through the array for that particular value. And so again, if we crank up the data size, we're going to see that it's going to get sort of exponentially slower. And obviously this is not good, because we all know if someone comes and asks you to write a script that can handle 1 million input items, then they're going to come back next week and ask for you to handle 10 million input items, right? And so what options do we have available for testing collection containment? Well, we have a hash set. So again, so I'm going to write this. I'm going to create a hash set, and again, the values we're working with here are all integers, so I'm going to type it integers. I'm going to start in a variable called mySet. Right. Okay. So now we have this hash set thing, whatever that is, assigned to a variable mySet, and it's empty. Right. I haven't added any values to it or supplied anything to the constructor. And so we're going to create a sample set from the same array we used before to avoid Evgeny coming after me and saying that I'm not testing the same input sets. So what I'm going to do here is, let's just have a look at that constructor. So the constructor for hash set has a couple of overloads, right? One thing to keep in mind is that you can supply custom comparer. This is extremely important if you're using a hash set with strings, because again, by default, PowerShell defaults to case insensitive matching, but .NET does not. So again, if you've strictly typed your hash set to contain strings, you definitely want to supply with a comparer that gives you case insensitive comparison, unless the point of what you're trying to do is to do case sensitive comparisons. Just keep that in mind. For integers, it doesn't matter, right? Like there's no such thing as case for an integer. So what we want to do is we want to take advantage of this overload right here, in which a single argument is taken, and this argument needs to implement something called IEnumerable over int, right? And so this is the interface we were talking about before, countable, sort of the lowest in the hierarchy of these generic interfaces. And so it needs some type that implements IEnumerable over int. And so here's probably the most useful trick of today. Any array that is strictly typed implements IEnumerable over that type. That does make sense. Let me show with some code. If I have something that is an array of objects, then it necessarily implements IEnumerable object, right? If I need an IEnumerable string and I have some way of obtaining a string array, string arrays implement IEnumerable over a string. So again, every time you see this weird interface name over a specific type and you can't for the world of you figure out what's going on here, create a strongly typed array of the same target item type and it will satisfy the constraint. So what I can do up here in order to feed my array data as the initial collection here is I am just going to type it as an integer array. And since PowerShell is very aggressive with all its conversion tactics and whatnot, PowerShell is simply going to unroll this entire array and recreate it as an integer array. It has no problem constructing these single-dimensional arrays, right? And so what's going to happen here is that all of a sudden the constructor actually gets an argument that satisfies the type constraint down here. So I can do that. Okay, no errors, that's pretty good. And so again, if we look at my sets, it has 1,240 items, just like the original array. Okay, so everything is exactly as we want it to be, right? So in order to recreate a situation up here where we were using the container operator, and for that reason getting terrible performance, in the case of the hash sets, much like with a dictionary, it also has a bunch of methods specific to its design. And what I'm looking for here is the contains method, right? So again, pretty self-explanatory. This method is going to tell us whether the argument that we pass in is already contained in the set or an equivalent value is in the set if we've given it a custom comparer. And so this contains method is going to output either true or false, perfect for where object, right? And so again, instead of array-contains or underscore dash in array. We're just going to do hash set contains here. And so we are going to regenerate the sample, and then we're going to run both of these. Give it a couple of seconds. It needs to generate the 1 million array up front. No, it doesn't need to do it, but it still needs to do the slow thing, right? Okay, so this is pretty significant, right? In order to search for just 1,000 items in this array that contains just 10,000 items, it takes almost a second and a half if you're just using collection containment operators on a regular array. Whereas the hash set, which again is a collection type that's optimized for this specific test, right? This is what it does the very best. This takes only 13 milliseconds, right? So that means that from the original strategy here, where we just use normal array with the collection containment operators, we now get a times 1,000 performance increase for insertions. So again, hash set really interesting. Oh, someone just pointed out that I actually gave this one another name, and this probably didn't actually test what I was intending to test. So let's just do it again. And let's repick the samples. Thank you, Christian. But again, similar results, right? Again, a minute and a half to make 1,000 searches throughout a 10,000 item array, whereas just searching for containment in the hash set is just a couple of double-digit milliseconds here, including the overhead from the measurement itself. And so again, hash sets super useful for testing membership of a unique collection, right? There are many other applicable use cases for hash sets where sort of the ability to answer that question, does this collection or does this set contain something or not, actually turns out to be really useful. So yeah, definitely something that should be part of sort of your PowerShell tool belt. Finally, if there's appetite for it, I am going to continue sort of the demo that I actually started with in the last session, developing class consciousness, about extending types for concurrency. So if anyone else is interested in that, I don't know if that's something people have time and willingness to sit through. Yeah? All right, a couple people list. Okay, let's do it. Okay, so in the age of concurrent programming or multi-thread programming in PowerShell, and when I talk about concurrent or multi-threaded programming in PowerShell, I'm specifically talking about a bunch of stuff that has been introduced in the last sort of major release pipeline, right? So I'm talking about things like for each object parallel, right, which defers to a thread job internally, the PS thread job module itself, right? But some of these things are also applicable to things that work in PowerShell 5.1, right? So how many people here have tried to sort of roll with their own run spaces or their own run space pools for parallelizing their workloads? Feel free to use the hand sign. Yeah, a couple of people, right? Yeah. So you might also already be familiar sort of with this paradigm of having multiple threads running concurrently that might need access to the same data. And so basically the problem that arises then is that none of these collections, right, the hash set, nor the dictionary, nor the stack, nor the list, none of these are implemented with thread safety in mind. That means that there's no safeguarding that two threads read and then try to update the same value, right? And so someone's mentioning here in the chat that in PowerShell, sort of in previous versions, back to version 3 at least, there is the option to sort of synchronize a hash table. So you can make a hash table thread safe by using this method called hash table synchronized. And you just pass the instance that you want to guard. And so This is now a thread-safe hash table. The implementation of hash tables synchronized is not the most performant. Like, you're going to take a huge performance hit. You are going to take a performance hit no matter what when you sort of take a non-thread safe collection type and try to make it thread safe, because what you need to implement is either locking or some sort of mutex, right, to ensure that no two people are trying to override or update the same value at once, right? And so again, there are generic versions or sort of generic equivalents for most of the types that we've already looked at. So again, if you're working with a stack and all of a sudden someone comes in and says like, oh, please parallelize this, or please use for each object parallel, or I want to use this with my run space pool, whatever it is, and your code makes use of the stack, well, then you can use a concurrent stack. You'll notice that this is a different namespace, right? System.collections.concurrent. But the idea is the same, right? These are also generic types. So again, if you've already been working with a generic stack, it's, again, as easy as just sort of replacing the type name with .concurrent stack. But unlike the previous exercise where we took the non-generic stack and replaced it with a generic stack, it's not going to work the same. And the reason that it's not going to work the same is that, again, we're taking a problem into account that we didn't have to take into account before. And so now some of these classes that go for both the stack, the dictionary, the queue, the back, and the synchronized collection, there's no way that they can guarantee that a specific operation succeeds, right? Because again, the list add, right, it's designed for a single actor to call it once, right? But if you have an add method and then you have 4 people or 4 threads calling it at once and there's a conflict, how do you resolve that conflict? And how do you signal that to the caller that it failed for some reason, right? And so what you're going to see is we can create one of these. Let's create a concurrent queue here. Just so we have sort of a reference here, I'm going to create a generic non-concurrent queue, right? So a non-thread safe, but generic queue. Also qualify with 0. Yep, not the queue I was looking for. Generic queue, string. So now I have a queue for strings. And then again, I'm being asked to sort of upgrade my code or refactor it to better take advantage of some concurrent execution scenario, right? And so what I'm going to do is, for comparison, I'm going to create a concurrent queue. And type argument is the same, right? It's the same data that we're interested in storing and exchanging here. And so I'm just going to let VS Code IntelliSense do the work here. But what you noticed and what we were talking about before, right? It has a bunch of methods. Yeah, clear the collection. It has a contains method. We can do containment. You can copy it to other collections, right? Exactly sort of the kinds of things you would expect. From a collection type. And again, DQ, NQ, these are the special methods that we use to put data into and take data out of a queue, right? Now, if we look at the concurrent queue instead, what we'll notice is that there's a bunch of these methods down here with try in front, and as this method implies, this is really wrapping like a try catch block. And so instead of you getting an exception when you try to enqueue some data or dequeue some data from a concurrent queue and it fails because of cross-thread access, instead of raising an exception, you're just going to get a Boolean back, so it's going to tell you whether it failed or not, and so you don't need to do a bunch of error handling. And so we can try that here, right? Writing to a queue is not a problem from a thread safety perspective, right? You sort of like just make them wait for each other. See? And so let's have a look at the method signature here. Okay, so I created my queue. Okay, so what is it saying here? So the try to queue method is going to return a Boolean, as I said, right? It's going to indicate whether the operation that we requested is succeeded or not. And then in order to facilitate the output, because we've now used a return parameter to indicate whether it failed or not, we need to allow try DQ to sort of write back to the variable we have here. You might have seen this before, the ref keyword in PowerShell. In order to pass a variable by reference, we can create a variable here. Variable. We're just going to assign null to it. And what I'm going to do is to use the special ref type literal, which is not a real type literal, and then the variable expression here. And so what's going to happen here is that we're going to pass the variable value by reference. So regardless of whether it's a value type or not, we're going to send the memory address into the queue, and the queue will then use that memory address to update the variable in the background. So by the time that the call to try to queue returns, something will have been assigned to variable on the other side. So anyone who has worked with a PowerShell parser knows this. If you want to get the tokens out of a parsing task, you need to use the ref keyword, right? Ref token list or whatever. And so the pattern you want to get into the habit of using here is make the method call and just wrap it in an F block, right? Because if this fails, then this is going to be false, and then we're just not going to continue with whatever operation we were going to attempt on what we're dequeuing. Whereas if try to queue return true, then we know that a value has now been assigned to variable, and we can start doing something with it, right? And so I'm just going to very simple variable value is to revalue. I'm going to do this, and as you can see, it picked the if branch, right? The variable value is ABC because the call to try to queue succeeded, and therefore a value was passed into and stored in the variable that we passed with the ref keyword. Okay, so now that we sort of all know that, and this is going to be the exact same thing. As I said before, concurrent stack is a concurrent version of the stack. Concurrent dictionary is a concurrent version of the dictionary. Concurrent queue is a concurrent version of the queue. Concurrent bag is a little bit weird. It was I've read multiple places that it was meant as a replacement for a list, but the problem with it is that it's unordered, right? It doesn't maintain insertion order. If that is not important to you, then concurrent bag might be just what you need in a simple like parallelization scenario, but otherwise use the synchronized collection type. What you'll notice is it isn't nested on the concurrent, but it is specifically thread safe, hence the name synchronized collection, right? So okay, so we have sort of a basis for understanding sort of the differences between like the regular generic types that we've been working with so far and these concurrent types, right? There are some safeguards in place to make sure that they don't fail in weird ways that you might expect them to do in a multi-threaded scenario. And we might sort of need to use the ref keyword in order to pass variables by reference. So keep these two things in mind, and then let's have a look at the example that I brought up in the developing class consciousness talk in Vienna. Okay, so I think this was the example we were looking at, right? I'm going to go through this again. Also, a pro tip, the using namespace directed in PowerShell is really useful, right? So instead of me writing system.collections.concurrent dictionary or whatever all over the place, I just declare that I'm using this namespace here, and PowerShell will automatically try to prepend it to any unresolved type literal, right? So PowerShell sees concurrent dictionary and says, there's no such thing in the global namespace. Let me try to prepend this, and now we don't need to, like the code gets a little less messy, right? This is not specific to the concurrent dictionary types. Like we could have done that with anything here, right? We could take system collections generic, pull it out of this queue string literal, and then just go, right, not important. Okay, so the example I brought up back in June is basically this, right? So I have a nested dictionary. I think someone in the chat mentioned when I said you can't do nested dictionaries when you're strongly typing the keys, unless they're a dictionary, of course. And so that's what we're going to do here, right? For the key type parameter, I'm going to use a string, just like you might with a hash table, right? And then for the values themselves, I'm going to use another dictionary type, namely a hash table. Now, what's worth noting here is that, again, the concurrent dictionary is thread safe, right? So if two threads try to read or write to the same entry, right, the same key of the concurrent dictionary at the same time, it has proper handling in place for making sure that these operations are atomic and that they don't overlap, so you don't need to worry about that. But the hash table is not, right? The hash table is not thread safe by default. So that means that in this sort of in this hierarchy of storage, when we fetch a hash table out of the concurrent dictionary, it's always thread safe. But when we fetch something out of the hash table, it's not necessarily thread safe, right? And so I'm just going to remove this. And so just so that everyone understands the example here, right? I create a dictionary. The dictionary can contain entries that are where the keys are strings, and the entries themselves are hash tables, right? So another dictionary. And then I'm going to use for each object parallel to in the background sort of run sort of 100 workloads in parallel. The effective throttle limit is going to be smaller, right? We're not going to run 100 jobs in parallel, but we are going to run more than one thread concurrently, right, at the same time. So what I'm going to do here is I'm just going to obtain a reference to the root dictionary that I've already created. You can see here we need to use the using scope modifier when working with parallel. Okay, so I have a reference to my dictionary, and then based on the value I've input, I pick one of two keys, right? And so then the next step is from the root dictionary, let's get the inner dictionary, the hash table that is associated with the key that we've just picked. And so here's something that might look a little weird if you're used to regular dictionaries. And so instead of me doing, picked and then just root key, the same way we would use an object indexer for a hash table, for example, what I do instead here is I call this method called get or add, which is sort of weird when you're used to methods like get and a method called add and a method. So this sort of dual responsibility, but there's a good reason for this, right? Again, since we're optimizing for concurrency, that is multiple threads working in parallel, you might have a situation where two threads at the same time decide, oh, you know what? I'm going to add a value to this particular key in the dictionary. And so if they both do that, then the last one is just going to overwrite the first value, right? So what you can say instead is that, no, we send in two requests for a particular key, and then we give a function, right? We give a script log, some code that the dictionary can then implement itself, or that the dictionary can then execute in order to figure out how to create the new dictionary entry. And so in this case, what's going to happen is that if an entry already exists for root key, then I'm just going to get that value, right? It would be no different than had I just done dict root key. But if the dictionary does not already contain the key, it's going to execute this in a thread-safe manner. Again, only the first sort of caller gets to actually have his key function executed. The next ones will just sort of get the already stored value here. This can be maybe a little bit sort of mind-bending that you have to inject PowerShell code into existing .NET types, but it works like this really is the way it works. Then finally, I'm going to take the inner dictionary, so the hash table that I pulled out of the concurrent dictionary with a given key. I'm going to take that, and then I'm just going to use like regular hash table syntax here to add one to whatever value is already stored in counter, right? And so I'm going to throttle this at 10 threads max. I'm not sure we're going to reach that, but let's execute this and see what happens. And so finally, what I'm going to do is I'm going to sort of unroll these hash tables that has the actual account from our experiment at the end of the run here. So I'm gonna. Okay, so what we see here is that the counter associated with the first key recorded a value of 49, whereas the counter associated with the second key output a value of 50, which doesn't really make sense, right? Because we asked for each object parallel to run 100 times, and then we asked it to update a counter in one of two dictionaries exactly that number of times. So we should expect that the total number of increments to these two counters should be 100, right? We'd expect both of them to be 50. But so as I just explained, what's happening here is that at some point during the execution of this code, two of the background threads that are running concurrently is going to do this operation overlappingly, right? So one of them is going to get the dictionary and the counter value. The other one is also going to get the dictionary and the counter value. Then the other one is going to the first one is going to update the value, and the second one is going to update the value to what it was just updated to, because it doesn't have the updated value from the subsequent modification, right? So again, there's nothing sort of stopping them from stepping over each other's toes, these multiple threads that we have accessing the same data type. And so this is why we see this. And again, it has some jitter, right? Again, out in the real world, usually it's not this simple, right? It's not as predictable how long it's going to take to execute code between two statements, because, you know, network computers, all sorts of uncertainty exists out there. And so we can sort of emulate this by adding a bit of jitter, right? Like sometimes it's slow, sometimes it's a little faster, right? So if I do this and I execute the code again, all of a sudden it gets way worse, right? Like we see multiple instances of sort of two or more threads fetching and then updating the same value, sort of overlapping with each other and stepping on each other. And so how do we solve this? Well, it's pretty simple, right? Again, as I mentioned, this is safe, this is not. So all we need to do is to turn the inner dictionary, right, this level down here, into something that's also thread safe, so that we can then use whatever methods is exposed by this. And so if we switch sort of to the safe example over here, what I've done is I've replaced the hash table type parameter with another generic type parameter, right? We can nest these as far down as you want to nest your dictionary hierarchy. And so that means that the next time this is going to be a concurrent dictionary rather than a hash table. And given that it's a concurrent dictionary, I now get all of these nice functional methods like add or update, right? So again, I want to add this key, but if it already, I want to add this key, right, and then execute this function to create its initial value. But if that fails and there's already a value present, then just update it and then use this piece of code over here instead to update it, right? So again, like we're sort of just doing value plus one, an increment, right? And so here, again, we don't need to worry about two threads executing this at once, because this code is being passed off to the concurrent dictionary to then sort of do that one by one, right? It can take care of making sure that no two threads are executing this or invoking this concurrently. And so this is the only change I've made, right? I changed the second type parameter in my sort of root dictionary to be another concurrent data type, and I replaced the addition operator with a call to this add or update method, and passed in some code to generate or update the values. And so if we run this now, all of a sudden there's no problem, right? There are no two threads competing to update the same value or the same entry at once, because the concurrent dictionary itself is taking care of that, right? Like back off, I'll do these one by one. And so again, this is sort of a super simple problem to a solution that is going to be pervasive once you sort of start digging into parallelization and multi-threaded code. Finally, before I say goodbye for tonight, I want to show you something else. And the reason for that is that, as we noticed here, this is sort of a limited list, right? There's a stack, again, might be useful. There's a dictionary, there's a queue, there's a bag, maybe not that useful. And then there's a synchronized collection that we can sort of use as a replacement for a list. But there's no set, right? We were just looking at hash sets and found that they were actually really useful for sort of keeping track of observed distinct values or stuff like that. And so the question is, where do we get a thread-safe version of a set? There's no set here. So the last thing I want to show you today is how you can use PowerShell classes to wrap, here we go, to wrap existing generic types and then impose thread safety on top of or around them. And so what I've done here is I've used the PowerShell class feature to create a new type called concurrent set. And as you might infer from the name, the idea is indeed that that it behaves the same way as a set, but it gives some execution guarantees for multi-thread code, right? And so I have it's basically composed of two objects here. So I have a hash set, right? A regular hash set. This happened to be something I needed for a set of integers, right? And so I have a set that I'm hiding away from the user. And then I have a log object, this type called a reader-writer log slim. It's a bit of a mouthful, the name, but the reader-writer log slim class is extremely efficient because it doesn't have any operating system dependencies, unlike like the musex class, the monitor class, or some other early.NET synchronization classes. It doesn't have any OS dependencies. It's only sort of process-wide. And it allows us to do upgradable logging scenarios. So that means you can obtain a log just for reading, right? So nobody changed this. We're looking at this right now, and then you can actually sort of upgrade the logging entrance to a write log if you then find out that actually I also need to update some stuff. So like, let me get in there as soon as it's safe to update it. And so how do you use this? Well, it's very simple, right? Write a simple constructor. Create the inner type. In this case, it's a hash set, right? And then for every single method of the hash set that we actually want to use in our use case, right, the methods we actually want to call in our code, this would be methods like set.add to add new items to the collection, or in this case is subset of, right? So like I have a list or I have another set or another collection, and I want to test whether that collection is a proper subset of a larger set of integers I have stored in here, for example, right? And so basically the pattern you want to follow here is you replicate the method signature from the original class, right? So if we look at a hash set of integers, it's Rob driving around to get me out of the room. Not going to work, Rob. I have my hash set here, right? And so if we look at the add method, right? So you basically just want to copy the method signature. So on PowerShell, we need to do a bit of rewriting, right? And so you end up with a method signature that completely matches the method signature on the inner collection type that you're trying to wrap. And then this is basically the pattern you want to do, right? Based on whether it's a write or a read from the inner set, this will sort of change the exclusion behavior of the log. So in this case, where we want to add an item, that is, we want to mutate, we want to modify the contents of the hash set as it is already, that's a write operation, right? We're updating, we're modifying something here. So what I'm going to do is I'm going to use my log to enter a write state. And I'm going to use try finally to call the requisite method on the set, right? So I'm basically just like proxying this addition to the set itself. And then in the finally block, make sure to exit your write log. The reason for using try finally here is that if you reach this point, then the log has already entered a write state and it's going to stay there until you explicitly exit it from the same thread. So without the try finally, we might run into a situation where sort of the program locks itself up because it enters sort of a write state without ever getting out of it. So again, try finally around exiting whatever type of lock you're entering, and then just sort of proxy the arguments to the method call of the collection you're trying to wrap. And then down here in subset of, we have the exact same thing, but here I'm calling enter read log. Again, it's a read log. It doesn't have to be exclusive amongst other readers, right? And so again, this also this is better than sort of your traditional log for the entire extent of the method strategy, because it means that we can have concurrent reads still, right? Multiple people can enter a read log at the same time and read the data as it is, as long as nobody's mutating it at the same time. And so again, a non-exclusive log, we enter that, and again, we sort of just proxy the callback to the set that is stored in the class itself. And then in the finally block, again, super important to place it in here, exit the log that you just entered on the same thread. As soon as you do this, I mean, we can try and execute this. All of a sudden, I have the add method that I generated. Let's just get member for this. You can see it has the add member, exactly the same signature as the set I was using. And so the reason for this, for outlining this sort of strategy, basically just copying the method signatures, is that now you can just use it as a drop-in replacement wherever you're using your hash set, right? So if anywhere in your code, in a script or a command line or whatever, you're using a hash set and you're using the add and its subset of methods, if for some reason you need to make it thread safe, then you simply just replace hash set with concurrent set, and it's just going to work because, again, the method signatures are going to be the exact same thing, and so all the method calls in your code, you don't need to refactor, everything just stays the same. So yeah, that was sort of my my introduction to safe concurrent locking for collection types. I hope this was useful. It's also been an hour and 40 minutes already. This is probably I think this is the longest. I think this is the longest psconf.eu session I've done so far. Jakob is asking, next up, generic class in PowerShell. Yes, there is a couple of issues on GitHub asking specifically for this. What I should note here is that the PowerShell classes feature can implement generic interfaces, bar a few limitations. But there are some limitations. Anyone who saw my talk, I Compare, last year will notice that implementing the generic version of iComparable, can I get that to? Well, basically, you can't do self-referential type parameters. So you can't do something like this, or using PowerShell syntax, right? So there are some limitations on the implementations you can provide for existing generic types, right? PowerShell is never going to accept some class as a type parameter of itself. And we also cannot use PowerShell to define placeholders or generic type definitions, right? There's no syntax available for me to be able to say, otherwise I probably would have, right? There's nothing here for me to say T and then, you know, indicate that T is a parameter placeholder or do something like this, right? There's no way PowerShell is currently going to recognize this syntax, but there are a couple of work streams where we're sort of looking at whether it could be a thing. Also present to that, I also want to mention Seemingly Science, Patrick Meinecke, one of the PowerShell team members. He shared a couple of months ago on PS Discord a set of type data updates, right? Basically an XML file that you can feed to update type data that actually makes link work, like link extension methods. So you can turn PowerShell into a little more of like a C# 3.0 up sort of clone if you want to. It's not very performant. It's also kind of ugly, but if you want to play around with these things, there are sort of patchwork solutions to some of it. With that being said, any other questions from? Let me just see if I missed anything here. No, okay. If anyone else has any questions afterwards, as I said previously, feel free to reach out to me on Twitter, GitHub, PS Discord, using my handle ISResetMe. I'll also be sticking around here at the conference for a couple of hours. But other than that, thank you very much.